All right, can you see? All right, on the board you can see that we drew a random sample of, each of us drew 4 heights out of 27 students that I had polled earlier today. And we found that of those 4, what the mean was and what the range was, and we graphed them. And we found the center of each graph. The true mean was 65, and look how close the sample mean was to it, even with just 8 dots or whatever we had there. So here we had 6 dots, that's all we had. So here the range, the true range was 9, but the mean of our range was not near 9. So we decided down here, you missed the graphing part, but the result is what's important. The result, X bar, is unbiased and range is biased. So that's the main result from that activity. Okay. Looking below, here is the same exercise, but they did it with a lot more samples. So down below, the 3 graphs that you're looking at, the center of all the means of the samples was 66.15. What the true mean was on the left is 66.07. So it shows you that this distribution right here of the mean is unbiased. Same result. It's just they did it with a lot more samples than you did. So that's what these 3 are. This is the regular population, this is the mean of the samples, and this is the range. How far off was the range on this one? The true range was 21. So Bailey, what was the range on this graph? The mean of the ranges.
21?
The real true mean of the ranges is 21, but when we did a sample, the range is this graph.
15.
Right here, what was the mean of these?
21 minus 2, 19.
Well, it tells you, what is it? The mean of the ranges on this graph is 10.21. Right, 10.21, is that a good one? Compared to the true range?
It has a 21 in it.
Pardon? What?
No, I was joking.
Alright, so the range is a lousy estimator. So we call, when it's a lousy estimator from a sample, we call it biased. So, alright.
Is it always one more than double?
No, it is not. That just kind of happened. Alright.
Yep, always.
It's been for the 2
Always.
I reminded you how we calculated variance. True variance was calculated like in chapter 2 of this book. And we took each data point, subtracted the mean, squared it, and then added the second data point, subtracted the mean, squared it, and then instead of dividing by n, we divided by n minus 1. That is an unbiased statistic. So next to that, where I was calculating and dividing by n minus 1, we're going to put in that blank unbiased. But when there's another way, and it's actually on your calculators, when they divide by n minus 2, and that isn't biased.
Why do we want that?
Yeah, so I don't know why they even do it that way. So if anyone teaches you that someday, you say that is a biased way to calculate variance. Divide by n minus 1. Alright, this last little graph here
Well, that's just
is
your biased opinion.
not described, so if you would describe what it is beside it so you'll know when you look back. This is a proportion, so we're graphing p hat, and the p hat is the proportion of this population that they tested or surveyed who have watched Survivor. So the final graph, you'll see a graph that has a histogram that looks like this, and it goes up and then it comes down. And over here is another one, and it looks a lot different. It goes up and comes down, but it's not as variable. It's more hugging the center like that. So do you see that graph? So P hat is proportion, watching, or having seen proportion haven't seen Survivor, the
What if
TV
they,
show.
Like, if they, does that count if they like watch 10 minutes of one episode?
Yeah, I guess it says if you've watched it, so I would say yes. I'm not sure what they would say. The true proportion of people who watch Survivor is 0.37. We'll pretend that's given.
Pretend that's given.
Yeah.
Can't we just have
It
it
is
be given
given.
since
You know,
you're
how would
giving
you
it to
really
them?
know unless you ask every person, you know? So we're gonna say
They
that
gave it
it
to
is
us. It
given
was
that
given.
the amount of people who, the proportion is 0.37 that watch Survivor. But what we have graphed here is 1,000 SRSs, 1,000 random samples, and each sample is 100 in the first graph. There's 100 in each sample. And what would you say the mean of that? Can you read, Allie, looking at the lighter graph, the one on the left, what would you say the center of that was? The mean of the proportions?
Between like 0.35 to 0.38, but like
Point-
0.37.
0.37 is right under the highest box. So and it looks fairly centered there. So I would say it is 0.37. So when we had that, we got P hat is 0.37. So we expected the mean of the proportions to be close or right on the true parameter because proportion P hat is unbiased. What happens here? Here the samples were 100 in each. Now I'm going to have each sample size is 1,000. So I'm still going to draw 1,000 random samples, but each one's going to have 1,000 in them instead of 100. So you see the difference between these two. Here the sample size was much smaller. We did it 1,000 times, but we had only 100 in this one, 1,000 in this one. What was the difference in the graphs? We still got the right parameter. P hat is still 0.37, but there's a major difference between the two, and that is in the spread. So we can make an observation from that. And when n was 1,000, there's not much spread from, almost all the data was very close to 0.37. Here it's spread out quite far from both sides of 0.37. So we say there's less variability in this one. So larger sample size have less variability or more precision is another way of saying the same thing.
If they did, never mind.
They're closer. Every single sample is closer to the true parameter. There's less spread in the data.
Oh no.
Because here, if you only had 100, you're going to find some of your samples said that the proportion was way higher and some were way lower. But when your sample size is large, that happens to a lesser degree. So let's put that in a statement that's important. This is still your day 2 notes. They just didn't fit well on one page today. So on your day 2 notes.
Which of these graphs are
This observation only takes place when the true population is 10
And the
times,
third one.
is more than 10 times greater than the sample.
It's the third
So,
one.
on the top on page 2, when n is greater than 10 little n, we've seen that before, variability depends on the sample size but not the population size. So that's quite astounding when you think about it. The sample size but not the population size. Suppose I had a scoop and I had a whole bag of kernels of corn. So if I take my scoop, I want a random sample of kernels of corn. So I'm going to dip my scoop into the bag and pull it out. It doesn't matter if I'm scooping it out of a bag or a whole truckload. the scoop doesn't know whether it's in the bag or the truckload. So you're going to get the same values, whether the population is a truckload or a bag. So that's kind of a interesting, crazy thing
Alarm.
about statistics.
Ding, ding, ding.
It
So-
doesn't matter if you scoop from a something or something something.
What?
If you
A what?
Scoop from a what or a what?
Oh, a bag or a truckload. Or a whole field. It doesn't matter.
Or a whole field of scoops?
Well, a whole big pile. All right.
Wait,
a whole
your
silo
phone
full.
is ding ding.
So you got a whole. Yeah.
It's been like that for a while.
Yeah, I know.
The
I
phone.
tend to ignore
phone
it.
is ringing.
Dinging.
This
Still go off.
is serious.
Okay. All right.
That's how the song goes.
We'll look at check your understanding later, but let's look at the little targets down there. I want to show you, I'm going to give you 4 shots, and you have to show where they will go if it's unbiased with a low variability. Thank you.
You're welcome.
So the first one is the
I
best.
hit my knee on
So give you 4 shots.
the
For them to have low bias, that means they're going to be unbiased. That means they're going to be right on the parameter, which is the center. And they're going to have low variability. They're going to be close to one another. So that's the first sketch. This is
It's the pig's
unbiased
nose.
and low.
What?
Never mind.
Pizza nose? Pizza nose.
All right, let's move over here where it's still going to be low variability, but it's going to be biased. Where would your 4 shots look like this time?
Outside from the middle, but still together.
Very good.
Wow!
All right, so you can put them anywhere. I'll put them out here. So they're not hitting the center, but they are close to one another. All right, what's it going to look like? Get some room here. When it is unbiased, but high variability.
They're all spread out, but still at the center?
Well, that's pretty good.
Pretty good.
Unbiased, but high
High good.
variability.
I meant to high five you.
So they're going to be near the center, and they're going to be spread out. So that's about the best way I could draw that. I think that's the weakest drawing. And lastly, we're going to have bias, but high variability.
So spread out all over the outside.
All right.
Well, no, but aren't they still centered around a certain thing? Or no?
They are when it's unbiased.
Ah.
No, but I'm saying, wouldn't they
Over here?
just be random, completely
Yeah,
random?
they are.
Yeah, I put
mine like
this.
I put mine like this.
But isn't what?
Yeah, but that's still
So they're
centered
not
around the
near.
center.
They're not near the answer. They're biased, and they're not near each other either. So.
But they're not like the same.
All right. So this is a picture of what these things mean.
Check
All right.
yourself before you wreck it.
All right. So your assignment, if you would
Take
look at
photo.
number 11, 13, 17 through 20.
11, 13, 17.
It's the ones that are listed on your day 2 notes. So
17
take a
through-
look
through-
at those and
Just 11, 13, 17, and 20?
17 through 20.
11, 13, 17, 18, 19, 20. So that's
11 what?
so that's 6 problems.
11, 13, 17 through 20. 11, 13, 17, 18.
Fourth one, nine.
Sorry, this is my thing for the people.
Okay.
This is
All right.
serious.
Very good. That's all I have for you today.
Yay.
All right. Is the video off yet?
Video is.